Yes, hi everyone. Thanks for joining this webinar. we.CONECT is giving me the chance to do this. Usually I'm giving my presentations on stages, which allows me to use my physical presence, which is not possible here. So it's a totally new experience for me. I'm super excited to be part of this. But anyway, so let's talk a bit about the level of autonomous driving and the HMI issues that are related to this one. I prepared a little analysis, which I will give you in the next 30 to 40 minutes, so that you get a little insight into my thinking and what I'm doing. The future of the automotive industry is unsure. We are facing a couple of disruptive changes that we see in the very near future. They are usually summarized under the CASE mantra, and CASE stands for connected, autonomous, shared, and electric. So the belief is that in each of these areas, in the area of connectivity, of autonomous driving, of shared or driving as a service, and electromobility, we will face disruptive changes pretty soon. One of the big challenges of my industry is to handle the entire thing and to move it up to the next level. So I will focus in this presentation on the A of the CASE mantra, which is the autonomous driving, or automated driving, or in this area, we have basically 6 levels defined by the SAE. I will not run through all of them, believing that you will know them. Basically, level 0 means no autonomy, full driver control. Level 5 means full autonomy, no driver control, meaning I will type in my destination and drive from A to B. And the levels in between are different levels of task sharing between the rolling robot and the human that we have inside. So the human becomes more and more a kind of implant god, pretty good when all the artificial limbs are attached. But these are not adhered with a human and cause quite some trouble. We can comfort ourselves with the fact that this development is not finished in the year 1930 Anno Domini. Faraway times will create new and unimaginable progress in this field of culture. They will raise the godlikeness. And this citation of Sigmund Freud, the Austrian psychoanalyst, shows pretty well the trouble we are in. We're humans, and as humans, we have limited capabilities. And the only thing we really have that gives us a large advantage in all this evolution and the fights we face in nature is the brain that we have. And with this brain, with this neurological structure, we have changed our environment dramatically, and we have also changed the tools that we can use. And whatever the definition of being human and when did the humans occur, but the use of tools is one criteria that is usually used. And these tools turn more and more into artificial limbs that we have. So we cannot run really, really quickly, but we can drive a car, which is an artificial limb that we have. We can communicate over large distances with an artificial limb called a smartphone. And we can gain data and manipulate data on any point of the globe with an artificial limb called a computer. So in 1930, Freud has foreseen all this, and he talks about faraway times that will create new and unimaginable progress in this field of culture. I think not even 100 years later, we have reached this level of what is unimaginable, and basically that we have reached this level of godlikeness that he foresaw with this one. This picture shows Heavens Triunfo. The Heavens Triunfo was the first example of autonomous mobility that we have. They were created in the theaters of the 15th, 16th, 17th century, and they put enormous amounts of effort into mechanics that created the imagination that these Heavens Triunfos were flying over the stage autonomously, without horses, without any external influences. They were flying over the stage. And the crazy thing is, never ever humans were sitting in this Heavens Triunfos, but there were always gods sitting in that. And so if we talk about autonomous driving today, or even maybe autonomous flying with these flying taxis that are under discussion, we have reached this level of godlikeness. So we are behaving like the gods that were sitting in the Heavens Triunfos in the theaters of the old times. And this again shows how the artificial limbs that we create are help us to reach a new level of being and a new level of living that we have. And as you may remember, Freud said that we have problems attached to the use of these artificial limbs, and these are basically HMI problems that occur in the interface or the interaction between a human and a machine, which is the field of science I'm working in, which is the business I'm running, thinking and acting in this area. So let's get back to autonomous driving. This picture is one that is shown in almost any presentation on autonomous driving. It was created in the late 50s, early 60s, and it shows the idea the scientists had at that time, the engineers had at that time on autonomous driving. You can see a family in the car with a game they're playing in the center of the vehicle. So the father is supposed to be behind the steering wheel, but he turns around and is watching the family playing the games. And on the streets, you can see these dotted lines. They are like rails, like magnetic rails that are used to steer the car, to keep the car on track, on the road and in the right lane. And so that was the original idea of how autonomous driving will be. And GM had the first ideas of autonomous driving in 1939. And I mean, we're almost 100 years later now, 80 years later now. And so, things have changed and technology came alive. And this is an example of a car, and this is just one car of many that shows this. I'm using this picture as an example, which has autonomy level 2. So you can turn on a button, you can press a button, you can turn on technology that helps you keeping the car on the road and helps you keeping the distance. And I'm saying helps you because it does it on itself to a certain extent, but the driver is still in the loop. The driver is still fully reliable. The driver has to keep full control and over the entire procedure at any time, which leads to the fact that the car is basically driving by itself in most of the situations you put it in, at least on highways. And every now and then you have to touch the steering wheel to show, hey, I'm still there, I'm still alive, I'm still awake, I'm still under control, I still have my mind on the entire process, I have my eyes on the road, and you can go on with the job you are doing. This is what we are having today. This is a production car. This is on roads, and I think we will see quite some growth in that. At the moment, we have 4% of all cars equipped with technologies like this, but particularly in Europe and in China and in North America, we will see enormous growth of this in a short time frame. This picture shows the next level of autonomous driving. This is probably level 3 or maybe level 4, which means the driver is allowed to pull him or herself out of the loop, can do other things. So this guy is reading a book in the car. He's leaning back a bit. I mean, if you really want to scare all the airbag and safety guys in our industry, you can show this picture, because this contains a lot of problems. So, for example, how can we position the airbag? Where exactly is the driver? Then we have objects between the steering wheel airbag and the face of the driver. But at the end of the day, this is an idea designers have and HMI guys have of how it could be when we reach the next level of autonomous driving. This is another example of autonomous driving in the near future. This differs a bit from the one we saw before, because we had this bring your own device scenario in here. So the lady brought her smartphone into the car and is using that inside the car. And we have the head-up displays supporting the driver, for example, communicating the driving mode, where it says self-driving and giving speed information and so on. So basically the same level of autonomous driving with a little different use case scenario we have in here. This then is again a new level of autonomous driving. We have driver and passenger turned around 180 degrees. So the car is driving to the left, the steering wheel is behind the lady. These two guys turn around, put up their feet, turn on their TV, and watch a movie, or do not watch it. I mean, if you have a look at their faces, I mean, he is sleeping and she looks totally bored, just like, why have I married this boring old fart that is always sleeping in front of the TV? I think this is a situation we all know from our homes, from our living rooms, and so this scenario, this car shows us the living room on wheels that we have here. This is again another level. This is when we reach the level 5 scenarios. This is an example from the CES that I took there. A picture I took there. No steering wheels. Maybe there are controls somewhere in the vehicle, but they're not for constant control of the car, but maybe for typing in a destination or telling the car, hey, let's have a stop over. I need a coffee or I need a restroom. So that will be possible. But then we have this lounge style interior that we have there with these seats in different directions, people sitting in there and doing whatever they want to do. I mean, the lady on the left has a smartphone, the guys on the right, they are discussing, they are talking. So probably these will be the activities that we have in this kind of people mover, and that will be the future of autonomous driving in a way. This is another example of a very small cockpit that we have here, also shown on the CES. We have a screen in the front, which is an interactive screen that allows me to manipulate vehicle functions from navigation to entertainment to air condition. And in the front, we have a row of screens which are either the entertainment screens on the left, on the right, or more driving-related information showing in the center of the screen. And this is another picture I took from an exhibit at the CES. Here, the big problem of people movers, empty spaces. I said, I mean, most of these concepts are as sexy as a dentist or a dentist office. And here they try to put in screens for entertainment, or maybe also for controlling the vehicle. And you can see the magazines here in front. So at least someone was thinking, what can we do with the people once they are in these people movers and being moved around? Okay, so let's get down to the point. Let's get down to the HMI issues we have when we talk about the different levels of autonomous driving. The basic point is that we talk about level 0 and level 1. Level 0 meaning no autonomy. Level 1 means one direction, either lateral or longitudinal, is controlled by the car, which is basically a lane keeping system, or a cruise control with a distance keeping. So in this level, the big question that we have is, how can we control the car? And when I started joining this arena of automotive HMI development in the late 90s, early zeros, the big discussion was how we will have a huge growth in functions that we have in cars, and all the drivers will be overloaded. We will end up with an aircraft-style cockpit in cars, and we will need to educate drivers on a totally different levels to be able to control everything they have in there. And even at that point in time, I had not believed that this is a serious issue, that we will find ways of making this one a little more easier and convenient. And if you have a look at, for example, this car, which is totally stripped down but offers a huge amount of functionality and a very small face, independent from the question whether this particular solution is a good solution. But I think we can all agree in the fact that this one is not an aircraft cockpit style, but this is very much stripped down. I mean, this takes over some metaphors from the tablet computing area, from the smartphone domains, so that we have all these things very much focused with a touchscreen in there, with the standard gestures. Again, whether this makes really sense in the way it's realized here is an open question, but it shows there are possibilities that we avoid the aircraft problem, that we avoid the overloading with the devices and functions of the driver. Okay, so let's move on to level 2. The basic question on level 2 is who's in charge, who's driving, who's doing what. Level 2 means the car does some things, the rolling robot is taking tasks, but I as a driver still have tasks to do, still have tasks to solve. And so this task sharing needs a clear communication, who's in charge and who's doing what. And this one shows a matrix which opens up all the possibilities we have. So on the upper we have the human things, I'm in control, or the other is in control. And on the left we have the machine things, I'm in control, or the other one is in control. And if we run through the fields of this matrix, in the upper right one, machine things, I'm in control, and the human things, the other is in control. That is uncritical, that is autonomous driving. That is independent of the level we have, but this is uncritical. We have clear task sharing at the moment. The machine is driving, the rolling robot is doing its job. The other one on the lower left is the human thinks I'm in control, and the machine thinks the other one is controlled. Also uncritical, this is called manual driving. This is what we have on streets out there, so definitely no point to discuss about. Then we have the situation, the human thinks I'm in control, and the machine thinks I'm in control. And this is somehow critical, because two are driving, and at the moment we have the paradigm that the human always overrides the machine, so we end up with manual driving. This is a solution we have. This is a good solution. This solves a lot. I think with more and more capabilities of the technology, with more and more issues the machine can solve, we need to rethink this paradigm, because there may be situations when it is better that the machine overrides the human. So, for example, the human is sitting in the car, falling asleep, pressing the foot on the gas pedal fully. The machine thinks, okay, the human is driving, and accelerates the car. But the car knows that there will be an accident soon based on the sensor data the car has. Then we should use this as a safety feature and break down the car and override the driver. So, yeah, the upper left one is at the moment solved, but it's not solved to perfection. I think there will be a bit of a discussion that we need to have in the industry. The critical area is the lower right one. The human thinks the other one is in control, and the machine thinks the other one is in control. This means no one is driving. And this is a highly critical situation, and because no one is driving. We have a vehicle on the road that is moving, and no one is in control. So this needs to be avoided strictly. So this picture shows an example on the communication between the driver, the task sharing between driver and car. And if you have a look at this cluster display, and there is a display in the center which has this bluish violet graphics, and in the middle lower area of that one there's a little yellow icon telling the driver machine is in control. I think from an HMI point of view, without bashing the GM guys too much, but there are better solutions out there, and we need to think about even clearer communication on the status of the car. Who's doing what? Is the car driving? Is the car keeping the distance? Is the car keeping the lane? Is the car capable of making turns? And how can I communicate to the driver that the car has reached its limits, and that the driver needs to take over? And from my point of view, we definitely need more than a tiny icon somewhere on a cluster display. So let's move on to level 3. Level 3 means the driver can pull itself or himself out of the loop. So we have a serious handover procedure between human and machine that we need to take care of in a way. So this picture basically shows the 3 different activities we have on a car like this one. The red box on the left, it means human is driving, so we are in manual mode. From my point of view, of course, driving is always a critical thing, and there's a lot of research, a lot of science about humans and traffic, but this is something we know and we can handle, and we as an industry have reached a pretty good level on handling the issues on that one. We have the handover from human to machine. That is the human telling the machine, hey, please take over, it's up to you, now you are driving. My feeling is we need some discussion on how to design this handover. Is a simple button press sufficient? We have this one in some cars out there on the road. I just activate autonomous driving or automatic driving, and then the handover is done. Do we need a confirmation? Can we allow it to do this with a voice command saying, hey car, please take over, or hey car, I don't want to drive? Is this a scenario or not? I think there is something we need to analyze and to discuss, but again, somehow solvable. Then the blue box on the right is showing machine is driving autonomous mode. So the machine is in control. The machine does everything that is required at the moment to allow safe driving. And so this is the autonomous mode with everything that comes with it, with all technological limitations. that we have there. But once it is active and once it is working, we have a clear status. And on level 3, the driver is allowed to pull him or herself out of the loop and do something else, whatever something else means. But this is allowed. And then we reach the handover from machine to human. And this, from my point of view, is the bottleneck of autonomous driving at the moment. On level 3, we have a handover time of a few seconds. So at the moment, discussions target towards 4 seconds that we have. Meaning the machine is detecting a situation where it cannot perform its task anymore, and it goes like 3, 2, 1, driver, it's up to you. And in this time, from my point of view, it's very difficult for the driver to prepare a safe driving procedure. So maybe the driver has the wrong posture, maybe the driver has something in his or her hands, maybe the driver is sleeping, or maybe the driver is involved in some kind of juicy activity inside the car. So something is happening in there and we don't know what people are doing, and so this handover procedure may be the critical one. The target, the core point in this one, the target that we need to reach is that we need to create situation awareness. Situation awareness is a psychological concept. It comes out of aviation. It was introduced there first. Pilots need to know everything about the situation they are in, which is basically who is where, who is doing what is the problem, and where does it come from, and what will happen in the near future, in a short time frame. A near future, and by means of situation awareness, means a few seconds, 5 seconds, 7 seconds, 10 seconds, basically the idea of what will happen next. And we have only a very short time frame, these 3, 4, 5 seconds, to build up a full situation awareness of the driver, basically teaching the driver the points I just mentioned, who is where, who's doing what's happening next. And scientific research shows that building up a full situation awareness in a complex driving situation takes between 20 and 120 seconds, depending on researchers, depending on the research environments. But one thing is clear, it is above these 3 to 4 seconds we have in reality. So at the end of the day, I don't have a real solution for that one at the moment. With some of my clients, I'm thinking about something like a situation awareness creator. Can we use some smart algorithms to create or some smart algorithms and some smart displays or some smart vehicle-to-driver communication to communicate the open points in a sufficient time frame to the driver that is understood? But from my point of view, this is a critical point in the entire discussion on autonomous driving. So let's leave level 3, move on to level 4. Level 4 basically includes all the technology we need for level 5. So technology-wise, level 4 is capable of solving almost any driving situation, but the driver is still responsible. The driver is still the one that has, at the very end of the day, the responsibility if something goes wrong. This will lead to very long times of drivers not driving. Maybe it's months, maybe it's years that my car is performing everything it is supposed to be performed by itself. And I can see this by myself. I am a passionate motorbike rider, and when I pull out my Harley in springtime after the long and cold German winter, it takes me quite some time, maybe 2, 3, 4 hours, 200, 300 kilometers of driving to get back all the old reflexes, to feel the same level of competence that I had when I brought the bike into the garage in October. So I can foresee a loss in competence of drivers. And if you have a look at this picture, this is taken from a flyer of a conference organizer. It was a conference on autonomous driving. And I think this is a level 4 car they are sketching here. And so you have the speed on the upper left saying 122 kilometers per hour. If you have a look at the lower right, it says a maximum speed allowed is 100 kilometers per hour. So I have no idea how an autonomous car knows it is allowed to drive 100 only, but in reality it drives 122. But anyway, on the lower left, it gives you the temperature, which I believe in this use case is definitely not an information you will really need. It tells you bad sight, schlechte Sicht on the lower left. I mean, I can see this, right? I mean, yeah, this again is an information that is maybe not the most relevant here. And then there is a red icon with cars in front of me trying to keep lanes, whatever this means. The core information is in the center, which is the red box that is shown there. It says Fehler Autodrive, Ausfallabstandswarnung, which basically means bug in the auto drive, failure of distance keeping the distance regulation. I mean, this is the core information that you need. There is a serious failure. And now imagine you haven't been driving for the last 2 years because the car did everything. You have a failure, maybe in a sensor on some computing device, and you need to take over in this situation. You have bad weather, you have bad sight, the car is driving too fast, probably too close to the car in front. I mean, this is a very, very complex driving situation, and you somehow need to solve that one to keep the competence alive. To round that one up, I had a discussion lately on this level 4 competence loss with a colleague, and he said we're going to force drivers into driving at least 1 hour per week to keep the competence alive. And again, this one totally contradicts the entire idea of autonomous driving, of having people behind the wheel that should not be there. So I don't know whether this is a good idea, but I think this is what pilots are doing. So they are forced into flying every now and then to avoid this loss of competence. Okay, let's move on to level 5. And so the colleagues from Ingolstadt call this the 25th hour, which is the time you gain while you sit in a autonomous car. And so in level 5, everything is run by the rolling robot. So you can totally go into something else. You can totally do whatever you want to. And so gain an average. We have commuting times of around 1 hour in the Western societies. So you gain this 1 hour, and you can do things in that. And I mean, this is a project called from Panasonic, shown on the CES a few years ago. This is show how they think you can use this time. I mean, there was in the background on the window there was additional information, augmented reality information, overlaid information. If you pass by a site, it shows you this is a castle of the 15th century, and so on and so on and so on. So you can educate yourself, you can entertain yourself. And then you have this table in the center, which contains 4 tablets. And with these tablets, you can do things. You can communicate. You can communicate with instances inside the car. You can show pictures and exchange them. You can communicate with external instances. You can educate yourself, you can entertain yourself, you can watch videos and so on. So this is an idea how we can fill this 25th hour with some useful stuff that people can perform. There's another one from Mercedes that was their vision a few years ago of how autonomous driving may be in the future. Again, here are displays on the doors and the door panels that allow communication, that allow augmented reality, that overlay information into things. Yes, again, the idea of putting displays into cars and giving people the chance to do stuff in there. Maybe this is the solution. I mean, these guys, they are definitely case. They are connected. They are driving, at least from their point of view, autonomously. They have a shared vehicle, and this is an electric car they're sitting in there. And these underground trains or public transports, maybe that shows us the way people want to be entertained, meaning bringing own devices in, bringing own connectivity in, which will release us as an automotive industry totally from the idea of how can we put HMIs into a car, what do we need to do, where can we put it. And I know some of my colleagues will really hate me for that because I will steal them of their jobs. But to be honest, this is a scenario I can foresee. If we have people movers in mega cities that move from A to B, people jump on, people jump off. This will be the next level of public transport, and people already solved the issue of the 25th hour by bringing in mobile devices. Okay, so that brings me to the end. Thank you for listening to me on this webinar. I hope I was able to deliver some information. I hope that you could gain something out of this. My contact data is in here. If you have some feedback, I know I'm not live on this one, so I'm not able to answer any questions right here on the stream. So at the end, send me an email, give me a call, send me a WhatsApp, or contact me on the normal social media you will all have, and ask me any questions you have. Thank you very much for listening, and thanks to we.CONECT for allowing me to be here on this broadcast.